So this is the Semester B exam review video. Keep in mind that this Precalculus video here is going to give you just a quick overview of how to do each of the exam review questions. It is our advice that you go through after you're done with this and redo the entire exam review on your own. Reprint it and redo it as many times until you're comfortable doing the questions without help. These are the formulas that are given to you on the exam review, from the exam review that are given to you actually on the exam. So be familiar with those and when you use those. I don't know why the law of cosines and sines is on there. It should not be, but everything else we covered this semester. So the first question here is asking you to sketch a graph of the function. Write the equation of any asymptotes and the coordinates of any intercepts. So this actually is going to take you a little while here. Okay, so we're going to start with our asymptotes. And we're going to take that denominator and we're going to set that equal to 0. And we're going to solve. And we're going to solve it by factoring. And the factors of 10 that add up to -3 are -5. Wow, this is going crazy today. -5 and +2. So we're going to have an asymptote at x equals 5. So you'd set x minus 5 equals 0 and solve. You get x equals 5 and x equals -2. So I'm going to go ahead and draw those in. So at -2, we have a vertical asymptote. And at 1, 2, 3, 4, 5. Okay, we also have a horizontal asymptote at y equals 0. And remember the rules for that is if the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is y equals 0. If they're the same, like if each was an x squared here, you'd take the coefficients, and that would be your asymptote, the coefficient over the coefficient for the leading term. And if the degree of the numerator is greater than the degree of the denominator, like if you have an x squared over an x, there is no horizontal asymptote. I'm going to go ahead and put this. This is a no calculator problem. So again, what we're looking to see is where this is going to. This is not going to have x-intercepts. So it says any of the intercepts. There are no x-intercepts. No x-intercepts because you've got asymptote going at y equals 0. And then we're going to just plug some points in and see what works here. So we're going to plug in maybe a value to the left of -2 here. So maybe x equals -3. When you plug x equals -3 in, -3 and then 3 over, I believe it's 16. So you get an idea as to what quadrant this is in. So this is the one section. I'm going to plug in x equals, to the right of this asymptote, x equals 6. And when you plug that into the equation and simplify that, we're going to get the order pair -6. And it looks like, I can't see this number. It looks like 3/8. So again, we are up in this quad up here. And then in the middle, let's go ahead and plug in when x is equal to 0. So we were going to have 3 over -10. So 0 and right there, -3/10 is going to give you the y-intercept. And they've gotten everything they asked for in the problem because they asked for the vertical asymptotes, the horizontal asymptote, no x-intercept, and what the y-intercept is, and a quick sketch of the graph. Again, this is a no calculator problem, so you cannot rely on your calculator to do that problem for you. Next problem here. Same process here. When we factor the denominator, we're going to get x plus 4 times x minus 2. It's the factors of negative 8 that add up to positive 2. So we have vertical asymptotes at negative 4 and a positive 2. We have a horizontal asymptote at y equals 0 because the degree of the numerator, which is x to the first, is less than the degree of the denominator, so it's y equals 0. Change colors here. So we have our horizontal asymptote at y equals 0, vertical asymptote at x equals 2, and our other vertical asymptote at x equals negative 4. And again, we're going to be checking points in each of these areas to the left, in the middle, and to the right. So I check the point negative 5. I'm going to check 0 and x equals 3 and find what those values are. So negative 5, it's going to be negative 9 over 25 minus 10 minus 8. So it's negative 9 over 7. So we're down in this quadrant here. When we check our 3 minus 4 over 3 squared, which is 9, plus 2 times 3, which is 6, minus 8. So it's 15 minus 8, which is 7. So it's negative 1/7. So 3 and negative 1/7 is going to stick it down in this quadrant. See what's happening in the middle here. Again, we're not going to have any x-intercepts because we've got that horizontal asymptote there. And then we need to figure out what's happening at x equals 0. That'll also give us our y-intercept. So this is going to be negative 4. 0 minus 4, negative 4 over negative 8, which is 1/2. So we're at 0, 1/2 for the y-intercept. And it should look like this. That's not a great drawing, but it's the right idea. Number 3. Our vertical asymptote is x equals 3. That's what makes the denominator equal 0. Again, you take your denominator, set it equal to 0, and solve it. And horizontal asymptote is y equals degree of numerator, 5x to the 0, is less than degree of denominator, which is x to the first. So that would be y equals 0, but we still have that 2 as a constant, so it shifts it up 2 units. So y equals 2 is the horizontal asymptote. So here we have this horizontal asymptote up here at 2. We have a vertical asymptote at x equals 3, and we need to figure out whether we're drawing this in these two quadrants or in these two quadrants. So you're going to just check a point to the right. So I checked, actually I'm looking for intercepts anyway, so I'm going to plug in x equals 0. And so this is going to be 2 plus 5 over negative 3. So that's 2 minus 1 2/3, which is just 1/3. So 0, 1/3 is the y-intercept. So we know it's going to look something like this. We need to find out what that x-intercept is here because they asked for it. So to find x-intercept, plug a 0 in for y and solve for what that value is. I mean, I drew approximately where it was, but we can do better than that. So we're going to subtract our 2, and we have negative 2 equaling 5 over x minus 3. Cross multiply, and we have negative 2 times x minus 3 equaling 5. And when we solve that and subtract 1, it's negative 2x equals negative 1. So I'm going to put this up here. X equals 1/2. So our x-intercept is at 1/2, 0, which is not exactly where we drew it, so it would be like kind of closer to there.